Hello, everyone. I'm Michael Marchuk. Welcome to the Transform Now podcast. In this episode, we'll be chatting with Sam Bhagwat, the founder and CEO of Mastra. He's also the co-founder of Gatsby.js and the author of Principles of Building AI Agents. So we're going to talk about a lot today. With a background in developer tools and a passion for open source innovation, Sam is helping to shape the future of AI development. So welcome, Sam.
Thanks for having me on here, Michael. It's a pleasure to be here.
I'm really glad you are here. So tell us a little bit more about yourself, because obviously this intro is very short.
So I've been doing open source JavaScript tooling for about 10 years. And what that means is that, as you mentioned so previously, I was the co-founder of a startup that made an open source framework for building websites. We ran that for several years. We kind of grew it to a few million of ARR and then sold the company. And I'm now working with a couple of the best engineers from that journey on an open source framework for building AI agents. And that framework is called Mastra.
Sure. But you are also the infamous author of this Principles for Building AI Agents. So tell us a little bit more about the book and tell us how many copies you've distributed now.
So it's kind of been a bit crazy. I mean, we've distributed about 100,000 copies so far. That's kind of since we wrote the book in March. We were sort of working with a lot of teams building agents, and after maybe a couple dozen whiteboarding sessions, my co-founder just kind of turned to me and was like, maybe you should write a book. And I was like, yeah, maybe we should. And we kind of, sort of rapidly wrote. We want to focus on kind of getting a good overview out quickly, and so we wrote and sort of printed a book in sort of a few weeks, and like I think whenever we've started sharing it with people, the reaction has just been really positive. People are like, oh, I understand that we need to be building these in our organization, but I don't know how we should go about doing it. I'm so glad to kind of get an overview of how to do that.
That makes sense. And like I said, you've had quite a bit of success. I've noticed on LinkedIn a bunch of folks commenting about the fact that how they are reading your book. And I thought it's interesting to see that this is really bringing a lot more attention to your team and given the material that's in the book right now.
We posted, and a couple of our posts had sort of 12,000 or 15,000 comments, which is just, a couple of orders of magnitude about what we were expecting.
So in your book, so we're getting right into it here, there's a bunch of different parts to it. So one is to talk about, you describe agents as AI employees rather than contractors. And how does this metaphor influence the way developers should think about agent design? Especially in terms of some of the memory, the autonomy, the tool usage that they're using.
So, one way to think about sort of employees is that they're very sort of context sensitive in terms of, if you kind of show them how to do a task and then walk through them how to do the task a few times, their performance on the task is going to improve drastically. If you give them like resources to get knowledge that they need to use in completing the task, they're going to do better than if you sort of didn't give them access to wherever that information was. And I think the big sort of drive, especially over the last 3 months, has been this term context engineering, which is this combination of memory, this formal concept of memory, which is the ability to search over the history of the chat with the user. But also tools that you can give agents that, can kind of go out and search, whether it's like search the internet or maybe search a larger knowledge base, an internal, document base that you have, and sort of get selected bits of knowledge that are relevant to the user's query and sort of bring it in back in. So I think, AI agents, like employees, are very sensitive to the quality of tooling and information that you provide them in terms of their ability to do the job well.
So you mentioned that these are context sensitive. So you're looking at this, they're employees rather than contractors. What's the difference from your perspective on this contractor versus employee concept when you're designing or building an AI agent?
Yeah, and I think part of it is the kind of the power that you sort of give them. There's and what I will say is that um I don't think that agents can be both contractors and employees. Um and I've kind of encouraged people to think about them not just as contractors but also employees. And so for example, um there's a legal firm a legal tech firm that's using AI to automate a lot of the tasks that a lawyer would do. And they start by designing their AI legal associate, and they ask sort of what, if the best lawyer in the world had the most time available to answer this question, sort of what would they do? How would they pull up sources and cross correlate the sources together? And it's not, because if you thought about it like a contractor, it'd be like, well, I have this one very finely delineated task and I need to just automate that task. But if you start thinking about it from, well, what's the best quality of work you could do? It might actually be that the way that you architect the problem changes, right? It changes because you say, well, what if we searched across a lot of knowledge? What if it was researching for a half an hour before it came back? What if it gave it the flexibility to do that before it came back with the answer? Like often you'll sort of end up with different designs of how it worked than if you said, well, if you approached it like some sort of an RPA task where you're like, I have this one thing and I need the agent to do like one thing.
So this is taking it from task specific or task authority to a broader process authority to give it more leeway or range to be able to actually gather the information and come up with a better outcome.
Often as humans, we're limited in our ability to do tasks well by time. You can't, if you have a research task, you can't say, well, just look up 200 sources and then try to cross correlate the sources together and, synthesize the information. You just can't do that. Right. But while there are some things that you have to make sure that agents do well that are easy for humans, but there are also things that are really hard for humans to do in well-defined amounts of time that you can just sort of stick an agent on, and it can do it better than a human. And it's interesting in that, the final work quality is obviously a sort of in some ways like a product of each of those tasks, right? So some of the journey of building a high quality agent is kind of raising the ceiling, and then some of it is like, sort of like raising the floor in some ways.
Gotcha. So do you see, building out these agents becoming sort of coworkers or employee? You talk about employees. Are these actual coworkers with folks that are in defined roles already, or do you see the roles changing as the AI agents take on additional responsibilities?
It's sort of like depends a little bit on the role. So there's a team building a veterinary assistant. So you'll have in a veterinary clinic, you'll have someone following around the vet. They're sort of taking notes and they're creating tasks from the notes. In that way, I think it's a very specific kind of role that person is doing, and the agent is kind of able to like jump right into that role and kind of do it well. There's other examples where you have agents acting as assistants. So there's a aerospace sort of agent tech firm, and a lot of times if you're an electrical engineer inside an aerospace company, what your job involves doing is reading these 100-page long part manuals, like 5 different parts that you might need to like hook up in some sort of circuit diagram with each other. And so like what they're doing is sort of they're changing that process from, well, the agent will read these and it will sort of give you the specs, it will extract out the specs, and then it'll kind of create this, well, we think this is how you probably want them. Is this right? Can you like adjust it or whatever? And then so all of a sudden, like you have this sort of like almost like, helper, but I think that's like a little bit more flexible. Like the way that's like the way that the engineer interacts with that agent sort of is more kind of variable to different kinds of tasks, because the scope of the tasks is much different.
So you're seeing that these tasks, based on what you're saying is you've got some tasks to be very simple, some tasks to be a little more complex or integrated. And depending on the type of agent that is employed at that part, you'll see them taking on more or less of the work depending on how that agent is going to be used in that situation.
Exactly. There's almost always a review process between the agent kind of presenting work and the human kind of reviewing work. But, as I think we all experience when we're sort of asking Claude or ChatGPT about questions that we may have, there's some times where it's a much simpler conversation. Just kind of okay, cool, this is what it is, and we're going to go on, versus where it's much of a more involved, like back and forth. No, it's not quite that way. I want it this way instead. Did you notice there's an error there? Can you fix it? That
a little more collaboration.
It's a little more collaboration. And I think that is very sort of dependent on both the sophistication of the agent that's been built, but also obviously the inherent difficulty of the task.
Yeah, that makes sense. So speaking of difficulty, one of the quotes you have is, you emphasize that AI engineering is not impossibly, complex. So that's a good thing. But what do you see as the biggest psychological or cultural barrier preventing developers from diving into these agentic systems to provide that value, provide those outcomes?
Yeah, I mean, I think there's the AI until very recently, let's say a year or two ago, was kind of this incredibly specialized domain that you almost had to work at like a Google or and a Facebook and Amazon in a very machine learning driven role where you would really understand the guts of how it works. And so because it used to be such a specialized domain, people outside the domain were used to deferring to domain experts. And we just got used to it's an AI thing, that's somebody else's job. Which is, when it was very complicated machine learning stuff, that's probably the right way of approaching it. But what's increasingly happened over the last year or two, right, is that as the functionality that we've needed to build agents has just become bundled into these OpenAI and Anthropic, APIs and ChatGPT and Claude, it's just now an API like other APIs that your developers, may be using. And now it's a more complex API. There's more parameters you can configure and tune. It's than most APIs, but it is an API. And I think we're used to, when we're doing some sort of an integration project, we're used to I know maybe the default way you configure it is this way, but the business requirements that we need for this project is that we actually need to configure it a different way. And we're used to that kind of back and forth. You can get used to that back and forth, and you have to do that back and forth to make sure that the resulting project meets the business requirements. And I think we're moving from a world where it's more of this just wow, magic machine in a box kind of thing, to more of it's just maybe maybe you're the business counterpart, not the developer. So you're not actually writing the API code, but you have a firm understanding of what's going on in the project and what dials you can tune and tweak. So I think it's almost it's the fundamental nature has just shifted a little bit over time.
That makes sense. So based on some of the things that you've seen, what are some of the most surprising use cases that you've been exposed to, without naming names specifically?
Yeah, no, I mean, I think the most interesting thing is to just see how widespread it has become in almost every industry. Not that every industry has become saturated with it, obviously, but that there are now, if you name an industry, there are now, 2 or 3 or 4 companies building agents that are specific to that industry. This has been this rise of the concept called vertical agents, which is exactly this, right? It's, hey, there's, in aerospace and in veterinary, in various in all sorts of across the medical spectrum, from insurance enrollment flows to sort of patient qualification to medical, to trial questionnaires and so on. There's so many different places. It's kind of PCs make these market maps of and you're like, wow, there's so many people attacking the problem on all different. And I think this is unusual it's unusual that this is all happening so fast. This is unlike anything I've been in Silicon Valley 15 years. It's unlike anything I've seen here, in the time I've been around.
But with certainly the pace of change has accelerated as we've seen this. And so you mentioned this whole verticalization of agents.
Mhm.
And to me, when I start thinking of that, I start thinking of, well, we've got general purpose large language models. Are we going
Mhm.
to see more verticalized small language models that are kind of coupled with or attached to some of these verticalized agents? Is that something you see going on?
Yeah, I think the interesting point is that the large language models have gotten I people thought that, and they thought that about like a year ago, that we'd have a lot of fine tuning of models for specific task domains. We do see some of that in coding assistants. But the thing about coding assistants is they're like what's called verifiable, right? You can run the code and you can see, does this code compile? Does it run? If I run it, does it throw me an error, right? Whereas it's less the case in other domains. Typically we're more seeing, well, well, there are some smaller, language models that get used to tackle specific tasks. Those tasks end up being like, essentially like, hey, can you fix this JSON structured output, right? Or like, hey, can you do this tool calling, function calling kind of functionality, like slightly better. They don't tend to be for specific vertical, although there are some very interesting, like people are like creating like weather models, for example, that are
Hmm.
feeding in vast amounts of weather data. So I think there are some fun examples, but I think for most of the time, it will be, the logic will be encoded in the agent. It will not be encoded in the model.
In the model itself. Interesting.
Yeah.
Interesting. So, going with this kind of general purpose model piece, in your book, you mentioned that you're kind of warning against over engineering with RAG. Okay. So, in your experience, where do most teams go wrong when implementing retrieval augmented generation? And what's your advice for balancing this, the simplicity versus the capability that they want?
I think in general, where we usually see people go wrong, and it's in totally understandable ways, they do they do the right thing. The thing they engineer the thing that was the right way 6 or 12 months ago, but things may have changed. And I think for RAG specifically, and I think that's just a function of things changing so quickly, right? And with RAG specifically, for example, one of the first things that we urge people to do is say, instead of, because with RAG is basically a data pipeline, right? You create this, you do a bunch of essentially ETL work, in order to create that database that you can now query. And we say, instead of going through that whole ETL process, what if you just wrote a function to search over the data you needed and gave that function to your agent as a tool, and just see how that works? I mean, maybe give it some parameters, right? That makes sense, like constrain the query in some ways that make sense for your business domain. We give the agent, so you can say, well, I want, to filter it by this thing, or I want to filter it by that thing. Don't just, but like, and start there and see how the agent does with it. And then if your agent sort of doesn't get the performance you need, then you can say, okay, maybe I should be, maybe these are the cases where it doesn't. And now we should be considering, maybe is RAG an answer to the specific retrieval problems that quality problems that we're having.
Do you think this is part of the, like, I want to say, the obsession with the new shiny thing? Oh my gosh, we have to have a vector database. Let's dive it in and make it happen. Is that
Yeah,
sort of how
and
you're
I
seeing
think
this?
vector, it's also the case that like the vector database in RAG was the new shiny thing in 2023. And it's interesting in that, like, now that models are more capable of tool calling, it's almost like replacing some of what people used to be doing with RAG. At least that's how to, like, there's people that like have, publishers that have millions of pieces of content. And in that situation, like, yeah, you should have a RAG pipeline. But, that doesn't mean that, like, for an average, business, or outside of a very content heavy industry, that would be the right solution.
Gotcha. So as these agents are doing their thing, you've discussed that agent observability is a core principle. So
Yeah.
why is tracing and evaluation so critical in agent development? And how do you envision these practices sort of evolving as agents become more autonomous and multimodal?
So I think the first thing to say is that, ultimately, we've kind of, agents are this sort of superstructure we've kind of built around this magic box, right? Which is the LLM. The great, LLMs are very powerful, but they're also non-deterministic, and those two things go very much hand in hand. And so you need to, like, especially, the closer you are to, especially the more downside there is from your agent giving somebody a wrong answer. If you think about
The
legal
risk.
or medical or accounting, the more you need to sort of put up some, like, you need to be able to see what your agent is doing. And then you need to be able to sort of, which is like the tracing part. And then you need to kind of have some automated tests that kind of ensure that your agent is performing to a certain quality. And that's evals.
Gotcha. So, based on that, but that sounds like that's not just observability, but some more governance principles that are wrapped around there. Where do you see these governance principles being applied? Is it in technology? Is it non-technical? Is it in the prompting? Where do you see them being applied?
So, I mean, you can, I guess, like, you can think about evals as like essentially the AI version of tests. So, your engineering team writes tests to make sure that when they ship new code, they didn't accidentally break your checkout flow or whatever, right? And it clicks through the things, and if it broke, then like your test will kind of like flag. And so, typically, you'll see sort of maybe it's not often that they run on every code change, but like often people run them, once a day. And you'll just kind of see, okay, like how we ran the set of, and they're more statistical tests, right? Than sort of like normal software tests are like they either pass or they fail. And if any of your tests fail, then you need to like go and fix it, right? Whereas this is more like statistical. It's almost like more of like what you'd see from a performance test. So like imagine you were just testing how fast your web page loaded, and there'd be some randomness if you measured that every day, but you could generally see if it's the load time's going down or if it's going up or which way. And so you can almost think about the sort of set of governance principles as well as the actual mechanics is kind of similar to that. You have kind of this, statistically, like this metric that kind of, there's some randomness to it. It can go up and down randomly, but it also kind of tracks your code quality. And then as a team, you kind of, as an engineering team, you sort of should have some standards around like, hey, this is what we want these metrics to be. And that's going to be very domain specific, right? So, but then also some code practices around like, hey, if we know that this code change is going to make our score go down by this much, we make sure to pair it with some other changes that'll make the accuracy go up to sort of compensate.
Gotcha.
So there's just kind of a variety of ways the teams handle this.
Gotcha. So as these agents become more capable and they have longer term memory and planning, how do we ensure that the observability tools keep pace with the complexity and the decision making that the agents are going to be doing?
Yeah, I mean, I think that one of the challenges that teams often run into is essentially you start the simple version of you make some like data set, and then you kind of use it to measure yourself, and then 6 months go by and you've shipped to production, and you're like, you go back and you look at your data set and you're like, wow, gosh, I mean, that was good for the time, but there's so much more that we need to do now. And I think it's just this thing where like your capabilities and your governance, right, your observability have to be evolving together, and that's something like, we often see teams working on this a lot as they're taking things into production, but it's also something that they need to kind of keep continuing to do after they go into production.
This is not just a one-time thing.
Yeah, I mean, if you ever hear an engineer saying, gosh, like, cursor is like really not good today, I don't know why it was like much better yesterday. Like, these things really do happen in like real world systems that like large numbers of people use for reasons that are not really clear to anybody. And so there's some of like, there's also like, you can have some guardrails, but also you should be, listening to your users and have some mechanism for users to surface feedback. And so there's, because no set of like perfect metrics is perfect until, they actually reflect reality.
That makes sense. So switching gears a little bit, you've been involved with open source for quite a while. So what role do you see open source frameworks playing in building out this AI agent ecosphere?
Yeah. The way to think about, agents and AI in general is that, again, like 3 years ago, it was a very academic domain, and now it's becoming a very practical domain. And so the tools that were sort of like known by a skilled set of specialists that have devoted years of their life to this, will suit them. But new tools need to exist to suit the software engineer who's kind of one of our sort of sayings is like every engineer should be an AI engineer or be able to be an AI engineer. But that doesn't that requires like knowledge, but that also requires like a new set of tools that makes that easy. What I will say is that, this isn't something that's happening for the first time. We've seen it like before. So if you look at like data engineering, or if you look at DevOps, these are both, fields in engineering that have emerged really over, 5-10, years ago. Right. But like at the beginning, like it was like a set of like knowledge that was like only available in large companies like Google that had to deal with data at scale, and skilled specialists, and like the tools evolved and the knowledge evolved and the best practices evolved. And, 2, 3, 4 years later, it just became much more democratized. And so, I think like we're in the middle of the same thing happening faster in AI engineering with both the knowledge and the tools.
That makes sense. So, one of the mentions you mentioned here is, things are changing very quickly. And you said in the book, we're all perpetual beginners in AI, right? So with the rapid change that we're seeing, how do you stay grounded and avoid chasing all of the new shiny things while you're still trying to actually create results?
I think, this is one of the hardest parts. I think it just requires a really good, head on your shoulders. And I say this like both on the individual level as well as like the team level. If there's like this new cool idea and like looks really promising, spend a day on it, maybe spend a week on it. Don't spend a month on it unless you've kind of gotten validation from the first two steps. You have to, but at the same time, I think that people there's also a lot of people that are like, for various reasons, like very like, if you look at like the artist community, they feel very threatened by AI. And so they're kind of very reactively reflexive in it. And like, oh, well, AI can't do this or AI can't do that. And they'll be talking about things that AI can already do. And you're like, just like, what? And so there may be people in your team or your organization that for various reasons, feel that way. And so I think, it's both, you have to be mindful of chasing the shiny object, but also, you don't want to be overly pessimistic or negative. You just view it as kind of like over the next, several years, if organizations don't AIify, they will get beaten and left behind by competitors who do. And so we are in the early innings of a very widespread AI transformation across industries, across, sectors, across locations, right? And so if you're working on an AI project, you are in that. It doesn't mean you have to solve all the problems today, but like you probably do want to figure out how to make some concrete, tangible progress that can be shared within the organization so other teams can learn from that. And I think if you approach it with that mindset, you're more likely, what we've seen is that you're more likely to scope your projects to a reasonable, like where this stuff shows up is in project scoping. We look at these projects sometimes, some of the projects people tell us about it, like, well, the technology isn't there yet, but like you're trying to bite off more than you can chew, so sort of like scope. And I think like if you have that the right mindset, you'll be able to set the right scoping and then to sort of make steady progress towards the goal.
So given that idea about scoping, because this is something that I think we've seen executives maybe miss the mark on, because they do see that from last week to this week, this brand new thing that is amazing that has just happened. And then next week they see another amazing breakthrough in something or other. So perhaps these executives are getting more optimistic than they should. So how do you help ground the executives who want to bite off more than they can chew?
Yeah, I think like one of the things that I sort of bring up in the conversation is that it really just depends on your team's level of AI sophistication. And if you have a team that's been working on, you know, we saw, so we were in Y Combinator, and out of about 180 founders building agents, there were about like 5 or 10 of them that already sort of built and in a couple of cases sold their agent company. And we just watched those teams like ship much faster than the other ones. And it wasn't because they were inherently better engineers or whatever. It was just because they'd seen the problem before and they knew the pitfalls to avoid. And so I would just, you know, and I would encourage execs to sort of scope for the level of AI sophistication that their team has. And then but the slope is in some ways like, you know, it's if you can ship a small project and bring a lot of people and like figure out how to make a lot of people involved in that and like get, you know, build the excitement, often like then you can do the one project will unlock the next 3 or 4. And then, you know, it's just the normal thing with execs, right? Often the execs are all talking to each other about AI. That doesn't mean that the directors are all talking to each other about AI or the ICs are all talking to each other about AI. And it's just be aware of what the conversations going on are.
Yeah, that makes sense. So to kind of wrap this up, we're looking out, say 6 months, maybe 12 months. Okay. I know that the crystal balls are pretty hazy these days. What do you see coming down the line that excites you the most?
The 2 things that we're the most excited about right now is sort of this, you know, these 2 problems called agent learning and sort of synthetic evals. So they both relate to kind of this core concept of taking the traces, like the raw logging that agents have, and using it to either automatically improve the performance of the agents over time or kind of automatically write like a set of tests. There's a few different approaches that are promising right now in the Valley. And I think that like, but nobody's really cracked either of these problems right now in kind of an automated way or even a semi-automated way. But I do think there's going to be a lot of progress over these things, and what that's going to enable on both sides is sort of an increase in quality, but also an increase in the complexity of the tasks that agents can accomplish in organizations.
That makes sense. Well, Sam, thank you so much for joining us today. This has been a wealth of information. And you know, folks, where can they get your book?
So you can, a few different ways. This is the book, by the way. You can get a digital copy at mastra.ai/book. And you know, I think like the physical copies you can find on Amazon.
Fantastic. Well, Sam, thank you so much for sharing with us today. Really appreciate it. And best of luck to you as you continue your delve into the new world here.
Yeah. And thanks, Michael. I really appreciated the conversation. It's been a lot of fun chatting together.